This table summarizes the equations of the parabolas, the form of the equation to use, the direction, the vertex, the axis of symmetry. Okay, so if you have a function or a quadratic function where x is the degree of 2, or where x is the one variable squared in the function, then you need to use the first form, y equals a times x minus h all squared plus k, where h and k are your vertex, and a decides if the parabola opens down or up. Okay? Now, if y was the variable with the second power, or the quadratic power, then you need to use the second form, which is x equals a times y minus k squared plus h. Again, your vertex is h and k, so watch out, because in this form, h and k are flipped, because k is the one that has the quadratic power since it follows the y. But again, your vertex is still h and k. The axis of symmetry, if it's x to the power 2, then the parabola opens up or down, so your axis of symmetry is a vertical line that has the equation x equals h. If the parabola opens sideways, then you have a horizontal line where it's y equals k, depending on the value of k. Everything else, you have the formula, like the focus. You just need to plug in h and k and a into the formula. So if you know your h, k, and a, you can calculate anything you need. The latus rectum, it's an absolute value of 1 divided by a. We'll discuss all of these later in future examples. So since we're using the second form, the focus is equal to h plus 1 over 4a, comma, k. So plug it in the order pair. We know that h, in this case, is a 3, plus 1 over 4 times a, which is a negative 1, comma, k, which is a 2. Now let's simplify. So this is just like saying 3 minus 1/4, which is 2 and 3/4, comma, 2. Now to find the directrix, it's x equals to h minus 1 over 4a, which is equal to, my h is a 3, minus 1 over 4 times negative 1. So minus minus makes a plus. So this is just equal to 3 and 1/4. And last is the latus rectum length, which is the absolute value of 1 divided by a, which is equal to the absolute value of 1 divided by negative 1, which is equal to 1.